Well, howdy there, folks. My name is Millard P. Moneybags III, and I'd like to introduce you to an impressive piece of kit that I call the Regressionista 5000.
Thank you, Millard. Hello humans, I am the Regressionista 5000 and my primary function is to perform regressional analysis, a key component of financial econometrics. I'm here today to talk to you about the OLS, but first let's examine what is involved with a regressional model. Millard, what do you know about regression?
Well, darling, that's easy. Regression is the evaluation of the relationship between a deterministic variable, say x, and a random dependent variable, let's call it y.
Very good, Millard. We assume that the y variable is stochastic and thus has a probability distribution. The x variables, on the other hand, we treat differently, assuming that they have fixed values and repeated samples, which is why they are deterministic.
We now plot a simple scatter graph given our data for x and y, like this one I prepared earlier. From this we can then eyeball the data to see if an obvious relationship exists.
Correct, Millard. Our next step is to draw the line of best fit, which is the line that most accurately represents any linear relationship between the data, as I have done here.
But how did you select the line? Surely you didn't just pluck it out of thin air.
I'm glad you asked, Millard. We need to choose a straight line that is as close as possible to all the data points when taken together. In order to achieve this, we use the general equation for a straight line, and add a random disturbance term to obtain the above equation. Do you know why we do this, Millard?
Oh heck girl, sure I do. We include this u term as it incorporates measurement error, unobservable determinants of y, and any other random influences that cannot be modeled. Now I understand why we include this residual term ut to improve accuracy, but you still haven't told me how you determine the values of the coefficients alpha and beta.
Why, of course. We look to choose alpha and beta so that the distances from the data points to the line of best fit are minimized. This is where we use the ordinary least squares estimator. The OLS method involves taking the vertical distance for each point from the line and squaring it. We then minimize the total sum of the areas of the squares in order to determine our line of best fit, as I have done here. As you can see from the graph, u hat is a distance between yt, our data point, and y hat t, the value estimated by our model. We are then trying to minimize the sum of the u hat square terms, which is known as the residual sum of squares or RSS. Are you still with me, Millard?
I think I'm following you now, hun. Just tell me this, what's with all this hat business? Are we heading for a rodeo?
No, Millard, this is econometrics, not a hoedown. The hat notation is simply used as these terms are estimates. Our alpha hat and beta hat are then calculated as follows.
Now hang on just one cotton-picking minute. Before you bury us in maths, I've got to ask, what is the difference between an estimator and an estimate?
My apologies, Millard. Estimators are the formulae used to calculate the coefficients such as alpha hat and beta hat. Estimates, on the other hand, are the actual numerical values for the coefficients which are obtained from the sample.
Okay, well I think I've got my head around what the OLS estimator is, but I'm still not sure I understand why we should use the ordinary least squares method over any other.
Great question, Millard. The model we have been using throughout is the classical linear regression model, which uses the following four assumptions to generate the residual terms. Thus the error terms have these four properties: 1. Zero mean. 2. Constant variance. 3. Independence from one another. And 4. Independence from the corresponding x variable. If these four assumptions hold true, then our estimators alpha hat and beta hat as determined by the OLS method are blue.
Well, I'm feeling pretty blue myself with all this regression mumbo-jumbo.
No, Millard. Blue stands for the best linear unbiased estimator. From this definition we can see that the OLS has the three desirable characteristics of a good estimator. 1. Consistency, 2. Unbiasedness, and 3. Efficiency. It is because of these properties that the OLS estimator is so highly regarded and often selected over other estimators.
Great job, R5000. Thanks to all y'all folks for listening. I hope you enjoyed this introduction to the OLS estimator. Call back and see us again sometime, you hear?